Hello everyone, welcome back to chemistry class. In today's lecture, we'll do numerical based on number of moles and number of particles. Before that, quick recap of what we have done earlier. As you know, 1 mole of any substance is equal to, or you can talk that in terms of molecular mass or number of moles. Molecular mass is sum of atomic mass of all the elements present in that substance. Whereas number of particles is Avogadro number, that is 6.022 into 10 power of 23 particles. And when I am saying particles, that means it can be atom, ion, molecules. So mole you can define in terms of molecular mass or number of particles. So here we will see numericals based on this. Either you have to find number of moles, molecular mass is given, number of moles present in that particular molecular mass, or you have to find number of particles, or both you have to do. Okay, let's start. First question, 52 gram of helium. You have to find number of moles in 52 gram of helium. Now atomic mass of helium is 4 units or 4 gram. So you know 1 mole of He means 4 gram, right? This is your atomic mass. That means 52 gram, how much mole it will contain? So what you have to do simply, so 52 gram of He means 52 divided by 4, and that will give you 13 moles. So 4 gram means 1 mole of helium. So 52 gram of helium means 13 moles. So it will contain 13 moles of helium. Second question, this much number of particles is given. You have to find number of moles in this much of particles. This is also for helium. Now you know, here you have written mole of helium in terms of molar mass. Now for this particle you have to write mole in terms of particles. So 1 mole of helium in terms of particle, I can write 6.022 into 10 power of 23 atom, right, or particles. So 1 mole of helium contains this much of particles. So this much of particles means how much moles of helium is present. So same like here, so 12.044. So this says you have this much number of particles of helium you have. So what is number of moles in this much of particles? So you have to convert this number of particles into moles. This relation I already know. So this means I have to simply divide 12.044 into 10 power of 23 by 6.022 into 10 power of 23. So this will cancel, and when you do this, you'll get 2 mole. So this much number of particles means 2 mole of helium. Next question, 46 gram of sodium atom. So number of moles, let's say in this question we'll find both number of moles and number of particles. Okay, now 46 gram of sodium atom. Atomic mass of sodium, it is 23. That means 1 mole of sodium is equal to 23 gram of sodium is equal to, it contains 6.022 into 10 power of 23 atoms, or I can simply write particles so that there will be no confusion. Okay, so this relation you already know. Now number of moles first in 46 gram of Na atom. So 23 gram, that means 1 mole. So 46 gram means 46 divided by 23. So you have 2 mole of sodium atom. So how many moles of sodium atom? 2 moles of sodium atom are present. Now you know in 1 mole this much of particles are present. Then how many particles are present in 2 mole of sodium? So simply to find number of particles you have to multiply this with 2 mole. So number of particles in 2 mole is this Avogadro number 6.022 into 10 power of 23 into number of moles. So we'll get 12.044 into 10 power of 23 particles are present in 2 mole of sodium. Now, before going to next question, some abbreviations. For Avogadro number, this symbol is used, N not. This is not no, this is subscript. To find number of particle, N is used. So this is your Avogadro number. This is your number of particles. M, capital M, this is your molar mass or molecular mass. Molar mass, you are talking in terms of gram. Molecular mass, you are talking in terms of atomic mass unit. Small m, this is your given mass. So this abbreviation also you can use here, or directly you can write like this. Next, 12 gram of oxygen gas. Here you have to pay attention. This is oxygen gas, not atom. For one oxygen atom, atomic mass unit is 16 gram. So here, molar mass of oxygen gas. Gas means this is O2. So 2 into 16, that is 32 gram. Now, 1 mole of oxygen gas is equal to 32 gram. So 12 gram means how many moles? So what I will write here is 1 mole means 32 gram. So 12 gram means 12 divided by 32. So that will give you something around 0.375 mole. So 12 gram of oxygen gas means you have 0.3, this is 0.375 mole of oxygen gas. And same now, if you have to find number of particles in 0.375 mole gas, then you know in 1 mole of oxygen gas you have 6.022 into 10 power of 22 particles. To find number of particles in this, you have to simply multiply by Avogadro number. So, number of particles in 0.375 mole. So this relation, the Avogadro number is same for each and every substance. So 0.375 into 6.022 into 10 power of 22 or 23, the same thing. So 23. So like by simply multiplying, you can get number of particles. 22 gram of CO2. Here you have to find both number of moles in 22 gram of CO2 and number of particles in 22 gram of CO2. So before finding out that, first you have to find molecular mass or molar mass of carbon dioxide. How to find? So I will do here CO2 means carbon 12 atomic mass. For oxygen it is 16. So 2 into 16, that will give you 44 gram. When you solve this, you will get 44 gram. Means for one CO2 molecule, you have 44 gram mass. Okay, that means this I can write as 1 mole of CO2 means it has mass of 44 gram and it contains 6.022 into 10 power of 23 molecules of CO2 or this much particles of CO2 it contains. So 1 mole of CO2, it means in terms of molecular mass we will say 44 gram. In terms of particle we will say this contains this much number of particles. Now in question what you have to do, you have to find 22 gram of CO2, number of moles in 22 gram of CO2 and number of particles in 22 gram of CO2. So 1 moles means 44 gram. So 22 gram means 22 divided by 44, that is 0.5 moles. This is your point. So 22 gram of CO2 means 0.5 mole of CO2 is present. And for number of particles, simply whatever number you are getting here, so this you have to multiply with this Avogadro number. And that will give you number of particles in 22 gram of CO2. 0.1 mole of carbon atom. Here already number of mole is given. You have to find only number of particles, nothing else. Okay. So 0.1 mole of this is point. So you know 1 mole of carbon atom means 6 or carbon means 6.022 into 10 power of 23 particles. Right? 1 mole of carbon means 6.022 into 10 power of 23 particles. So 0.1 mole means how many particles? Simply you have to multiply 0.1 with this much number of particles. So that will give you answer as 6.022 into 10 power of 22 particles are present in 0.1 mole of carbon atom. So the most important thing that you have to remember, this I will write here. Whenever doing numericals like this, the most important thing that you have to remember is 1 mole you can write in term of molar mass or molecular mass, or you can write in terms of number of particles. If you remember this thing, then you can easily find out or you can easily solve this numericals. Number of particles, this is fixed, known as Avogadro number, whose value is 6.022 into 10 power of 23. Somewhere you will see number of molecule or number of atom, that depend on particular substance we are talking about. So but this number is fixed, 6.022 in 10 power of 23. And molar mass, so it depends on the substance we are talking about, elements present in that substance. Okay, if it is oxygen, simple oxygen atom, it is 16 gram. If it is water, so you have to add these, so it will give you 18 gram. If it's simply hydrogen, it is 1 gram. So when you talk about molar mass, you have to write this in gram. When you talk about molecular mass, instead of G, you write 18U, atomic mass unit. Okay, please go through this numericals and see. It is very important to clear this concept here in 9th class only. Otherwise, you will face problem in 11th class. I will give some more numerical based on this concept. So solve that, try to solve that, and if you find any difficulty, please contact me. Thank you.